So next up, to talk about what they're working on at CIMRE, is Ryan MacIver.
Thanks, Kyle. So here talking on behalf of CIMRE about the development of their muck assessment tool, aka the mud rush detector. So mud rush is an ongoing concern in underground mines, particularly in cave mines, where the rapid release of liquefied solid and fluids are released into the mine. So this is an area of concern that CIMRE has identified as worthwhile to address. And so what we're working on right now is a hardware and software platform to help measure directly at the draw point the conditions that contribute to or cause mud rush events, so thereby improving safety. So instead of relying on humans doing surveys with various tools, visual inspection, replacing that with a hardware tool, feeding into a platform that also integrates with the operational data, environmental data to get a more robust geohazard assessment. It's very niche. We're not the technology platform, but we're working more on the sensors that are tying into those technology platforms. And we're doing it in this paradigm that everyone's been talking about, which is really delivering that end result, that end assessment into the systems, rather than just being another piece of hardware out there, which is, you can download an Excel spreadsheet from, or you can copy on a USB key. So that's what we're working towards. So where we're at right now is we're at the V1 mobile prototype stage. So we're a couple steps behind what's been presented so far, but we've gone through the benchtop testing, so individual sensors, testing on static samples of known composition, and that worked out really well. So now we've developed a mobile prototype that can be taken to trial sites as well, to the mine, to the muck pile or the draw point in the underground, battery operated, connected, again, like connected data going into the cloud, et cetera. And we've got our analytics pipeline running on the data. So we've got this tool. We're working on building up our assessment model. We have very positive conversations ongoing with a partner to get out to their site. We're quite excited about that for various reasons. Product validation. It's important to get this get a client behind it saying, yes, we want your technology at our site. But also, a lot of the product is image analysis and machine learning models. So it's critical to our ongoing development as well, and our strategic development, to get that data into the system, both to validate, but then also to build the next iteration of the product. Great. Okay, so mud rush, it's a mining-esque crowd here. Mud rush in a mining operation where it does occur is an ongoing concern, daily concern, sending out surveyors into the mine to collect information about the moisture content, stability, as well as particle size and other factors. As well, there's a myriad of other operational and environmental factors that feed into mud rush, the history of the mine, et cetera. But the management of mud rush events and occurrences is ongoing. It's a day-to-day fact of life in these mines. And so first and foremost, huge safety concern. So autonomous vehicles are used routinely in cave mines where mud rush is a risk, but not always, because it seems to be the less preferred mode at the moment. If possible, to have human-operated machinery at the site is the preferred method. It's a safety concern. So damage. So these a couple images up there of mud rush events, liquefied miniature underground landslides burying everything in view. So multi-million-dollar losses of equipment like that, loss of life, injury, and so this really has to be avoided. Lost production, and so safety is the first driver that we thought of, but more and more, as we talk to operators, it's more about getting a better view point or making these events more observable and the conditions that are contributing to them more observable. So that's where this hardware system, point measurement system comes in. And we're working towards, this is our V1, so we've got a unit that can go to site and take the measurements, but the eventual vision is to have a network of these deployed, taking measurements and feeding the data into the analytics model, informing about mud rush risk potential, and it becomes a productivity tool like any other sensor at this point, informing more, being able to decide, okay, we're redeploying over here. Moving people and machines around in the underground is complex. Short-term planning is complicated when you have hundreds of people and machines moving them from site to site, getting out of harm's way. Okay, so as I mentioned, current approach is manual visual survey, human in the loop, and we're looking to automate that using a sensor network and using the equipment that we're developing. And so this is the kind of the hardware manifestation. Where we also have a software platform, which is kind of looking a bit like a geohazard assessment platform at this time. We're also working a bit with University of British Columbia, some of the researchers there with their mud rush machine learning models, et cetera, to help kind of see what this future vision of our product can look like, to tie in our outputs into models of that type. So that's where we're at right now. So we're at the V1 field product stage. We need to get out to site and demonstrate that this thing actually works, to start showing what it can do, but also to start getting that critical data we need from the mine site. You can only go so far with simulated samples and simulated sites, locations. Again, looking towards getting these things mounted on autonomous vehicles, tied into platforms that are being developed, as we've heard in the last few conversations. So it's pretty benchtop right now. We've developed this unit. It's in a Pelican case. It has a probe. And so it's really a survey tool right now. It looks like a piece of hardware, but it's network connected, and we can run it the pipeline on the edge, or also on a local or remote server. And so it's got a couple of depth cameras. We've got a high resolution close-up depth camera collecting color and point cloud information, as well as scene view camera, LED lighting. It's so bulky, the hand-carried unit, because it has a shortwave infrared spectrometer in there, and that's collecting high-resolution spectra, which is quite useful. We use it for moisture content as well as mineralogy. And so we take those outputs. We're running multiple stages of machine learning models to extract various pieces of information from these sensors, detecting the muck pile, pulling apart the fragmentation pattern. So again, hints of other tools that already exist are in this. Particle detection, but also multi-stage moisture detection, so looking for free or standing water, as well as supporting that with the shortwave infrared as a backup for a real physical-based measurement rather than just relying on the machine learning model. And so right now we're looking to label draw points based on particle size, moisture content as high, medium, low risk. So mud versus dry versus flowing water, fine particles, and clay. So that's where we're at right now. And we think the real value of this is, again, eliminating the human from the loop. There's always a need to have someone looking at the data and looking at the high resolution images as a backup. But it avoids having a human at the site that's a potential hazard to evaluate a hazard, which is, it's a bit contradictory. So making, and as well as integrating with this ability to make systematic assessments, making the data available to allow improved hazard awareness and improved productivity and short-term planning activities in the mine. So where we're at right now, we're still building up the assessment models, looking for partners either with access to representative samples or maybe easier to access site locations, And we're also looking for a longer-term partner that is interested in developing the technology, but potentially as an investment or taking a stake in the technology itself. Thanks.